Good morning to all. This is Dr. S. Kasirajan, Associate Professor, Department of Aeronautical Engineering. I am taking subject for some students, aircraft design, in the academic year of 2026 to 27. In the aircraft design, first unit topic is design concepts, aircraft design. The introduction of the aircraft design, it's a very complex engineering task for create the own design or innovative something designs. Okay, we need to concern the specification of the airplane, selecting type of determine of the geometric parameters, and selection type of the power plants, and structural design and working out details of entire construction. And we have to prepare the fabrication of the prototype. Finally, we need to check the or analyze the airplane performance, stability, and structural integrity from the flight test. Here, the flight test means we need to conduct the wind tunnel testing. By using the wind tunnel testing, we can analyze the airplane performance and we can improve the aerodynamic efficiency. We have to reduce the drag efficiency also, and also by using the modeling softwares, we can analyze the aerodynamic efficiency also and structural efficiency, structural stability also we can test. We can analyze the structural stability by using the modeling softwares. Here, the three phase of the aircraft design is there. The main objectives, our subject is we are going to design the aircrafts. So previously, we need to analyze the what are the feasibility is there to design the project, to complete the projects. What are the feasibility is there? We need to take the market surveys and also we need to observe the customer requirements. These are the very important to design the aircraft. Then we are going to analyze the environmental conditions or operating conditions, which type of environmental conditions. Based upon the environmental conditions, we have to design the aircrafts. Then we have to study the design requirements. What are the requirements from customer side? Particularly, what type of aircrafts they are going to they want to design. Okay, they want to expect what kind of design, particularly in the civil aircrafts or commercial aircrafts like that. After complete the feasibility studies, then we go to start our preliminary design of the aircraft. In the preliminary design, we need to consider the weight estimation of the aircraft and geometrical parameters and selection of power plants and what are the equipments is there, arrangements of the equipments we need to concern. Then control system also we need to analyze. Okay. Then after complete the feasibility of the project studies and the preliminary design, we are going to design the project. It's a third phase of the aircraft design. After complete the market surveys, operating condition, design requirements, preliminary weight estimation, geometrical parameters, power plant selection, and equipment arrangements, control system, everything is everything is arranged or conclude. After that, we are going to test the models by using the internal testings or else some modeling software also is there. After complete the testings, we have to prepare the detailed drawing. Based upon the above data, we have to create the detailed drawing. Then we need to choose a final selection of the power plant. Which type of power plants is suitable for our design? Power plant is nothing but it's a engine, aircraft engines. Okay. Then we are going to fabricate the one small prototype models. After designing, everything is satisfied means we need to go to the manufacture the aircrafts. Here we can classify the aircrafts based upon three ways. The first point is purpose of the airplane. What's the purpose? We are going to design the aircrafts, but what's the purpose? Which purpose we are going to design the aircrafts? For commercial purpose or fighter jet purpose or ambulance aircrafts? Different purpose is there. Agriculture purpose is there. Commercial means civil aircrafts is there. Cargo aircrafts is there. And ambulance aircraft is there. Okay. And a rescue plane, airplane also is there. And sailplane also is there. And the fighter jet aircraft also is there. So what's the purpose? We need to analyze the purpose and observe the details. Okay. Based upon that, we can classify the aircrafts. Then aircraft configuration. Aircraft configuration is here is nothing but aircraft wings. what type of wings we are going to choose for our design. Okay, different types of wings is there. Okay, what type of wings we are going to choose our design, and what type of fuselage structures we are going to choose for our design, and tail section also is there, and also what type of equipment and power plants and control system also is there. So based upon that, we can classify. Okay, and these are under coming under the aircraft configuration. Then third point is Mach number. Mach number is nothing but the speed of the aircrafts. Generally, we can classify the speed of the aircrafts: low speed, medium speed, high speed. When the low speed Mach number, the low speed aircraft is a Mach number is less than one. It's a subsonic. Okay, it's a subsonic speed of the aircraft. If Mach number is equal to one, means it's sonic. Is compared to subsonic, the sonic speed is more. Okay, so less than one is the Mach number, the subsonic. Equal to one is the Mach number is sonic. If greater than one, Mach number is m greater than one, means it's one kind of supersonic. Supersonic means aircraft speed is compared to other subsonic, sonic is very high. So generally we can this type of aircraft is coming under fighter jet aircraft. So fighter jet aircraft having the Mach number more than one. Okay. So based upon the speed also we can classify the aircrafts. Then you can see the picture here. From the picture, we can easily differentiate the aircrafts. The first pictures clearly we can observe this is the fighter jet aircrafts. Okay. The second picture we can clearly observe this is the commercial or civil aircrafts, the passenger aircrafts. Okay. In the fighter jet aircrafts application areas, we are using in the defense sector or warfield. Okay. The commercial aircrafts we are using in civil aircrafts, passenger transport purpose they are using this type of aircrafts, but the both aircraft having unique design. Here our objective is we are going to design the aircrafts. So based upon the purpose, we are going to design the aircrafts. If I am going to design one fighter jet aircraft, means I need to take the data, old data, and some standard books also is there, military standard books also is there. I have to collect all the data from there and take the reference point from the old aircrafts. Okay, based upon that, we can create the new design of the fighter jet aircrafts. Similarly, the commercial aircrafts, we are going to take the data from the old aircrafts or reference aircrafts also is there. And also some standard books also is there. In our Indian government, DGCA, approved standard books also is there. So from the data books, we can collect all the details. From based upon that, we can create the new designs. And also it will be satisfy the customer requirements also. So customer requirements is very, very important. Okay. And market survey is very, very important. And economically, we need to consider all the factors. Okay. So here we are mainly discussing about the classification of the aircrafts. Based upon the classification of the aircrafts, we are going to design the aircrafts. Okay. Based upon the wings, how can we classify the aircrafts? The pictures clearly shows the first picture is shows straight wing aircrafts. Straight wing aircrafts. You can see the pictures. This is small compact aircrafts. This type of aircrafts generally we are using the agriculture purpose or pilot training purpose. Okay, they are trainer aircrafts. Okay, so you can see the pictures. The wing location will be located on the above the fuselage. Above the fuselage and wing shape also it's look like straight line. It's look like straight line. So this is called the straight wing aircrafts. The straight wing aircrafts. Okay, and also you can observe some cantilever, semi cantilever type of wings. You can see the frame. It's connected to the fuselage to the wings. Fuselage to the wings. Some connection is there. Okay. So this is another name is called semi cantilever wings. The second image, the swept wings. Okay, the swept wings, you can observe some angle from the fuselage to the wings. The wings position is located some inclined ways from the fuselage. So it is backward, swept backward wings. Okay. So based upon the design, wing design, we can classify the aircraft. The third image, swept forward. Okay, swept forward wings. And fourth picture shows the oblique wings. So from the four pictures, we can see the observe four types of wings is there. Not only four types of wings, many types of wings is there. Again, we will see. Check this pictures. Variable sweepings. Variable sweepings. First image is shown, and for second image shows delta wing. Okay, it's look like triangle shape. Okay, so delta wing. Third image shows the biplane wings. Fourth image triplane wings. Wing position, we have discussed about here, wing position. Wing position means wing will be located on the fuselage in lower surface or mid surface or upper surface. Okay, so in that way we can classify low wing aircrafts, mid wing aircrafts, high wing aircrafts, and also shape of the wings. Delta wings, swept to backward wings, swept to forward wings, variable sweep wings, okay, straight wings, oblique wings. These are the wing shapes. Based upon the wing shapes also we can classify the aircrafts, and also wing position also, based upon the wing position also we can classify the aircrafts. Then number of the wings also we can here play the very big role. Okay, the last two image you can observe more than one wings is there in the aircraft. The third image having two wings is there. And fourth image having three wings. Okay, generally last two type of aircrafts there is it is a ancient model, old model. Okay, these two aircrafts generally used in the agriculture purpose and some training purpose. This type of aircrafts they are not using the fighter jet like that. Modern ways. Okay, modern aircrafts, n number of aircrafts came. Okay, this is the old models. Now they are using this type of aircraft for agriculture purpose and the training purpose only. Okay. Again, we can classify the aircraft based upon the tail section. Okay, by using the tail section, we can control the aircrafts from left to right, right to left, or else we can mention the yawing movement of the aircrafts. Okay, left to left turn or right turn. By using the tail sections only, we can control the aircrafts. In the first image, you can observe the T-tail section. Okay, in the T-tail section having the horizontal stabilizer also is there, vertical stabilizer also is there. Okay, in the vertical stabilizer, one rudder control surface is there. By using the control surface rudder control surfaces, we can adjust the aircraft left or right or yawing movement. Okay, you can see the image clearly. It's look like T wave, T shape. So that reason we can call this type of tail section as T tail. The second image we can observe the twin tail. Twin tail is there. Okay, it have two tails. Tail section is there. By using the two tail is there, you can operate the fighter jet aircrafts. Okay, highest aerodynamic efficiency is there, and easily it can able to left to right. Suddenly it can able to turn left or right by using that tails twin tail. Okay, so that reason this type of tail section we are using in the fighter jet. Okay, in first airplane, it's a one kind of cargo aircraft carrying the more payload, and also wings. Also, you can see that it's a high wing aircraft. Okay, wing location is a high wing. Okay, it's a cargo aircraft. Here, the second image, this is a fighter jet aircraft. So we need more maneuverability, highest maneuverability efficiency required for this aircraft. So that reason, here we are using the twin tail for particular designs. Based upon the design, tailless, horizontal tailless also is there. You can see the third image. This is also fighter jet aircraft. But here we don't use the horizontal tail. So that reason this type of tail section is horizontal tailless. It have only vertical tails. Vertical tails only is there. Okay, why it doesn't have the horizontal tail means where you can see the wings. It's a delta wings is there. It absorbs a lot of area. Okay, by using that wings, we can operate the aircraft up and down or pitching movement. So that reason it covers more area now. So that reason we don't require the horizontal tails. So we are required only for vertical tails for turning the aircraft left or right or yawing movement. Okay. The fourth pictures, you can see the picture. It's a unique design. So one kind of unique design. Okay, it doesn't have the vertical tails. Okay, you can see the wings in the wings tip. On black images there now. Clearly you can notice. Okay, on black images there. There is one small control surface is there. Okay, by using that control surfaces, we can operate the aircraft left or right, right or left. Okay, by or else yawing movement. Okay. This is a very unique design. It's a vertical tailless aircrafts. Okay. Generally, this type of vertical tailless aircrafts We are not using broadly, but unique design. Wherever the customer requirements based upon the purpose, so this kind of design is possible. But this kind of design is not suitable for commercial airplanes because it carries more payload. So this is a very, very unique design. Some private jet also it's have. Okay. Small compact aircraft. That time they are using this kind of design. Then we are classifying the aircraft based upon the landing gears. Okay, totally two type of landing gears is there. One is fixed landing gears, another one is non-fixed landing gears. Fixed landing gears is another name is a non-retractable landing gears. Non-retractable landing gears. Where we use this type of fixed landing gears means when we are going to design the small compact aircrafts, only two-seater or one-seater like that. Okay, so that time we don't need the retractable landing gears because its cost wise also very high, and also the design also it leads to very complex design. Okay, so that reason this type of compact aircrafts it's enough for fixed landing gear. And also you can see the image, the wings, no, semi cantilever wings is there. Okay, so that reason we are using this type of landing gear, and also helicopter also having fixed type landing gears. Okay, why we are using fixed type landing gears in the helicopter means when we design the landing gears, it's a complex design for the helicopter. Okay, retractable means it's a one kind of folded type landing gear after taking the aircraft from the ground. Okay, it will certain altitude conditions. So landing gear will be retained the original position, like foldable type. Okay, it's get into the fuselage structures. So they are one kind of complex design, and also it gives more efficiency for commercial aircrafts. When we use the more payload, when we can carry the more payload aircraft means that time the retractable landing gears or non-fixed landing gears is best choice for that design. Okay, the fixed type of landing gears, so normally we are using small compact aircrafts. The cost is also very, very less compared to retractable landing gears. Okay. Then again, we can classify the aircraft's design based upon the propellant. Propellant means power plant in engines. Power plant engines or aircraft engines. You can see the first four images. The first four images is coming under the category of gas turbine engines. You can see the eighth image in a gas turbine engines. Okay, the first four engines also gas turbine engines is coming under that category. Okay, the turbo shaft engines, turbo propeller engines, turbo fan engines, turbo jet engines. In the turbo shaft engines, where we use it in the helicopter, we are using turbo shaft engines. Why means the horizontal rotary motion is converted to the vertical motions. Vertically, the motion will be transferred by using that shaft. Okay, so that reason this type of engines is suitable for helicopter purpose. The turbo propeller engines, it gives less speed, thrust efficiency. It gives more or less the thrust efficiency compared to turbo fan engines, turbo jet engines. So that reason we are using this type of engines in small compact aircrafts. That means 80-seater passenger aircrafts. Compared to turbo fan engines, turbo jet engines, they give very low thrust only, or else subsonic engines. Subsonic engines means Mach number less than 1. Okay. In the 80-seater aircrafts, it's suitable for this type of engine is suitable for 80-seater aircrafts, turbo propeller engines. When we go to increase the more payload of the aircrafts, 250 seaters or 1000 seaters. Okay. That time we are going to prefer with the turbo fan engines. Turbo fan engines gives more efficiency compared to turbo shaft engine or turbo propeller engines. Okay, it carries a more payload. So that reason, we are using the when we require more payload to carry the more load. That time this type of engine is suitable for that design. Okay, based upon the more payload also, we can increase the number of engines also. Types of engines one category. Another category is the number of engines. Okay, 2, 3, 4 like that. 2 engines, 4 engines, 6 engines. Okay, like that way we can increase the number of engines. Based upon the number of engines also, we can create the design. Okay. Then with the turbo jet engines. Turbo jet engines gives more efficiency compared to above 3 engines. Okay, it gives Mach number more than 1. Okay, obviously this type of engines used in the fighter jet aircrafts. Okay, not only fighter jet aircrafts, some private jets also is there. Okay, so private jets, they are also using some private jets. Also, they are using turbojet engines. It gives more speed, with more thrust power, Mach number more than one. So that reason, this type of engines is preferable for fighter jet. And also, when we require more speed of the aircraft, that time it's suitable for this engine. Then ramjet, scramjet. Ramjet, scramjet also having unique design compared to above four engines, turbo or else gas turbine engines. Okay, the ramjet, scramjet engines, they are using the spacecraft and space shuttles. Okay, then rocket engines. Rocket engines we can again classify liquid rocket engine is there, solid rocket engine is there, and hybrid like rocket engines there. Hybrid rocket engines means nothing but it's a combination of the liquid rocket engines and solid rocket engines. And nowadays, our ISRO scientists, they are launching the rockets by using the cryogenic engines. Cryogenic engines have some unique concept is there, but it gives more efficiency compared to liquid rocket engines, solid rocket engines, or else hybrid rocket engines. Nowadays, we are using the cryogenic engines. It has certain working principles on propellant maintenance and -degree Celsius. Everything is it's there. So again, coming classes we discuss about clearly. Okay, based upon the engines, we can classify the aircraft. Okay, which type of engine suitable for which type of design. Okay, then we choose the power plant is play the very big role for aircraft design. Okay, then here number of engines also we need to discuss. Then location of the engines also we need to discuss. Generally, in commercial aircrafts, location of the engines is engine will be located below surface of the aircraft wings. Okay, aircraft wings, and also based upon the payload, we increase the number of engines also. Two engines or four engines or six engines. So very big size. Suppose we are going to design very big size of the aircraft. That time we are using the or increase the number of engines also and types of engines also. Okay. Then remaining three image you can observe the engine location. It's a tail section is located. Particularly in the fourth image, the fighter jet aircraft is there. Here we are using the turbojet engine. The location is tail section and also it is located into the aircraft. It's connected with the fuselage also. So it's a one kind of buried engines or submerged engines. Okay, buried engines, submerged engines, and the types of engines, location of the engines, number of engines. These are the very big role. The power plant, very big role, play the very big role to create the new design, innovative designs. We need to choose correct power plant and the location and the types of engine. Okay, which type is suitable for this our design, and the number of engines also. How many numbers is required for our design? That also we need to calculate for the design aircraft design. Okay, these are the very major factor, major consideration we required for create new design. Okay, based upon the classification also, we can observe a lot of details for the create the new design. This is a very basic observe details. Okay, and also UAV, some control configured vehicle is there, unique design also is there. Then we discuss about UAV control configured vehicles and some unique design also is there. Then we discuss these are the details in later classes. Okay. Thank you so much for giving this opportunity. Thank you so much.